So today we're starting November 6th. We're looking at differentiation of combinations of functions. So we have the product rule. And last time we looked at the product rule, we said that if y is equal to uv, where u and v are functions of x, then the dy by dx would be equal to u multiplied by the differential of v plus v multiplied by the differential of u. In other words, I would leave the first, differentiate the second, plus leave the second, differentiate the first. Quotient rule, this says if y is equal to u over v, where u and v are functions in x, dy by dx would be equal to v du multiplied by du by dx minus u multiplied by dv by dx all over v squared. So let's go straight to the application. So example 16, I'll do 16, and then I'll ask you, I could easily ask you to do both 16 and 17. Let's go on the next page. It says combination involving trigs, but that's not a combination. So 18 is not 19. 19 is not a combination either. All right, so let's look at example 16. Where to find dy by dx when y is equal to e to the x ln x. E to the x ln x is a product. And the product rule says that if y is equal to uv, dy by dx would be equal to u dv by dx plus v du by dx. All right, so let's go straight for the answer. So dy by dx would be equal to, leave the first is e to the x, so it's e to the x, differentiate the second times the differential of the second, which is when you differentiate, so this is the first and this is the second. So I leave the first, then differentiate the second, 1 over x, plus differentiate the first. The first is e to the x. When you differentiate e to the x, you get e to the x. Leave the second, which is ln x. All right, so my final answer is that dy by dx would be equal to e to the x over x plus e to the x ln x. If you wish, you could factor out the e to the x and say that this is e to the x. And inside the bracket, you'd have 1. You'd have 1 over x plus ln x. All right. So that would be the differential in 16. Anybody have any problems with it? Anybody have any problems with the approach? No?
No, sir.
All right, good. So 17 now.
So I was just wondering if I was supposed to do something after I finish that part.
No, there's nothing else to
Okay.
do. With 17, this is a quotient. This is a when to do 17, you're going to apply quotient rule, which says that if y is equal to u over v, dy by dx would be equal to v du by dx minus u dv by dx all over v squared. All right. Now, obviously, you could take it apart and call u what? U is actually x plus 1, and v is what? 2x, 2x squared plus 1. So you could take it up apart and sort of use find du by dx, find dv by dx. You could have done all those pieces separately and then bring it in back at the end to get the answer. Or for me, I would prefer to just go straight for it. So it is still using the quotient rule, but without going through looking at individual pieces. So I just go straight for the answer and say dy by dx would be equal to v. So remember, u is at the top and v is at the bottom. So it would be equal to v, which is 2x squared plus 1. That's v multiplied by the differential of u. U is x plus 1. When you differentiate x plus 1, you get 1 minus u, which is x plus 1, multiplied by the differential of v, which is 4x. And this is all over v squared, which is 2x squared plus 1. And that is squared. Let's simplify the numerator. We're going to have 2x squared plus 1 minus 4x squared minus 4x, and this is all over 2x squared plus 1 squared. My final answer is going to be, that looks like 1 minus 4x minus 2x squared all over 2x squared plus 1 all squared. That will be the final answer. Any issues, any problems, any concerns?
Sir, again, I don't have to break it down any further.
All right, so here we have differentiation of combinations involving trigonometric functions. Example 18, where to differentiate sine 4x plus 6. We're going to use chain rule. So dy by dx, we're going to differentiate the outer function, which is sine. When you differentiate sine, you get cos. So this is cos 4x plus 6. And then you have to multiply now by the differential of the inside function. The inside function is 4x plus 6. When you differentiate 4x plus 6, you're going to get 4. So our final answer is 4, the cosine of 4x plus 6. Number 19. Now we're asked to differentiate y to the fourth power. Sorry, we're asked to differentiate y is equal to sine to the fourth power x, and we're asked to do it with respect to x. Everybody should bear in mind that y is equal to sine to the fourth power x is the same as saying y is equal to sine x raised to the fourth power. So we're going to treat this as a power differentiation. So it's both power and chain. So the differentiating the outer function is power differentiation. And then we have to multiply by the differential of the inside function, which is sine x. So dy by dx would be equal to, the 4 comes to the front, the sine cube x. Then we have to multiply by the differential of the inside function. The inside function is sine x. When you differentiate sine, you get cos. So it's cos x. And so our final answer is 4 sine 3x cosine x. All right, it's that simple. Just two simple steps.